Hello friends, today we are going to discuss a number system problem that how we can convert decimal number to octal number. So in this video we'll discuss couple of approaches. One is that we will write our own program that how we can convert number from decimal to octal system, and another is that how we can use the classes provided by JDK like integer class. So there we will have a couple of methods, so we'll briefly touch these two methods as well, that how we can achieve the convergence from decimal to octal system. So but our primary focus would be that how we can write our own program, that custom program. So what we do first we understand in this video that how the convergence happen mathematically. Then we write our program here in this demonstration as well, and then we move to the editor and then we see the execution results. So this is the agenda of our video. So let's start. So before we go ahead, so let's understand what is octal number system, right? So octal number system, we represent the octals in the radix of 8, right? So which means that all the numbers in octal should be range from 0 to 7, right? So we don't see any number greater than 7 like 8, 9. It's not a valid number in octal system. Like if I say 118, right, it is not a octal number because we see that range is 0 to 7, right? So 18 is not the number to be represented as in octal system, right? If I say 299, right, for that sake let's say 29, right? So this is also not a valid number, right? Because 9 is not in the range of octal system, right? So that is briefly about what is octal number system, right? So the number uh, which we represent in the range of 0 to 7, right? So that is the octal number. And in this video now we will see how we can achieve this particular result, right? How we can achieve it, right? So it is 8 and 0 to 7. Okay, so let's understand it, how we can mathematically perform this conversion, right? So so let's see, if we have to convert a decimal number, right? Decimal, we know it is base 10, and octal I already discussed, it is base 8, radix is 8, right? So let's convert this number 100, which is of decimal representation, and we know that target radix is 8, so we will divide this decimal number by 8 because we want to represent it in the 8 number system, and that the representation would be 0 to 7, so we are dividing it by 8, right? Before I started, right? So the logical flow from decimal to octal, decimal to binary, and decimal to hexadecimal, it is almost same. We already publish the videos for decimal to binary, and we'll publish decimal to hexadecimal in a day or so. So you can, if you understand one of this video, so all will fall in place. Logical flow is same for the convergence from decimal to another number system. Okay, so let's divide it. So what we do, so we have to note down two things once we perform the this convergence. So first we understand what is remainder. So 18 100 by 8. So first let's divide it. So 100 by 8, it would be 1, right? So then it will get 2, 20, then it will be become 8 2, right? So remainder would be 4 in this case. Okay, so again let's divide 12 by 8. It is not fully divided, so 8 by 12, it will go till one quotient, and remainder again will be 4 in this case. Let's divide 1 by 8, right? So 1 by 8 is not fully divided, so quotient will be 0 in that case, and remainder would be 1 in that case, right? because 1 cannot be divided by 8, so 1 by 8 becomes 0. So that's it. Now we have reached 0, so we cannot perform rest of our operation. So we got our octal which we are looking for. Like we will read our octal from bottom to top. So what is octal? It is 1, 4 and 4, right? So decimal representation of 100, its corresponding representation in octal system is 144. Okay, so what we are doing here, so we are dividing the number by target radix, which is z, and we are first noting down its remainder, and we keep on dividing it till we reach 0. That then we cannot perform any further operation, right? So every step we note down the remainder and we keep on dividing the next quotient. We note down the remainder and we keep on dividing the next quotient, right? So this is briefly how we can achieve the conversion, right? So takeaway is that we have to note down the remainder and we have to divide the number, right? So this is one step, and second step is we have to keep on performing this operation till we are greater than 0, right? So like 1 is greater than 0, 12 is greater than 0, or 100 is greater than 0, right? So this will become our base condition when we write a program. Okay, so let's quickly write a program, and let's see. You can follow me along here. So uh, slowly you will understand what we are trying to achieve. Once we write the program in the editor, you will understand much better. You will have much better idea going forward. So let's be patient. Okay, so uh, now let's write our program. It's in very simple term what we have discussed, right? So let's first of all write the signature of our programs, and suppose our method would return string, right? So let's name our method. So it is decimal to octa, and we are taking input as a number. Okay, okay, so let's change the color a bit. Okay, so very first thing what we are doing, so we are first calculating the remainder, right? Very first thing we are doing, when we are dividing by it, we are noting down the remainders. Okay, let's do it the same way in our program. So to calculate the remainder, we have the modulo operator divide that is given by our framework, Java framework. So it is modulo operator. It will return us a remainder. So whatever thing we are doing, 100 by 8, so it will return 4. So this guy will do modulo operator. Okay, so next thing what we are doing, we are dividing it, right? 100 by 8, right? So second step is let's divide the number by 8. Okay, and third thing what we are doing, so whatever base condition, like we will keep on performing this division operation 100 by 8, 12 by 8 or 1 by 8 till we reach 0. So our base condition is we will keep on performing this particular operation till our quotient is greater than 0. Okay, so let's write that base condition as well. So we'll use while loop, right? So if I say while number is greater than 0, so keep on performing this particular operation which we are doing as of now. Okay, let's indent it. Okay, so the, so that's it as of now. So basic logical flow is complete. So we have a number and we are noting down its remainder, and every step we are dividing it by 8 so that we we keep on performing our operations so that we can calculate our octal number system problem, right? So we will do the dry run, so you will further understand how we are doing it. So let's to perform that dry run, let's devise and write an string builder so that we can every step we can note down what is happening. Okay, so let's use string builder. I will tell you why we are using string builder, so just be patient for a couple of minutes more. So it has some logical introduction here in our program why we are using string builder. Okay, now let's take our example. Our example is 100, right? Our example is 100. So we want to perform uh, conversions from 100 decimal to the octal representation. So our input number is 100 here. So we are checking whether number is greater than 0. Yeah, 100 is greater than 0. Okay. So what we are doing next? We are noting down the remainder, right? So what is remainder here? 100 by 8, remainder is 4. So let's do 4, right? So let's write it down the 4. Now next thing we are doing it, we are performing 100 by 8. 100 by 8, we know it is 12. So number would become 12, right? So number would become 12. So I am commenting it out. Okay. So next thing what we do, right? We will store our remainder, right? Because we have to uh, make our octal number system, right? So we'll save it. If we don't save it, it will keep on looping and the value of remainder will be gets updated every time. So let's save it in our builder. So builder has an append method, so where we can simply append our integer, our remainder here. So what will become in the first case? So in our builder by default will be empty for the first case, right? Once we initialize it. So once we append the remainder, first case, it will become 4, right? Now after first iteration, we'll again go to the while loop. Number we have seen now become 12. So let's make it as 12 in this case. Okay. Now again we check number is greater than 0. Yeah, it is greater than 0. So then we perform 12 modulo 8. So 12 modulo 8, we know remainder is 4. So remainder would again become 4. So let's simulate it by updating it to 4. And then we dividing number by 8. So number is 12. 12 by 8. 12 by 8, we know that it will be becoming 1 in this case. So now number would become 1, right? Okay, so next thing we are appending to our builder so that we can get our number back. Now, so let's say a builder dot append, but what we are appending remainder, so it will become 4. So let's be patient. We'll see quickly see its execution also once we go to the editor as well. So let's be patient a bit. Okay. Now let's go to the next iteration of while. So number is 1. So let's update our number now. It is not 12 now. It has become 1. Now number is greater than 0. Yeah, it is greater than 0. Now let's calculate its modulo. So 1 modulo 8, remainder is 1, right? So let's make the remainder 1. Okay. Now next step, number by 8. 1 by 8 is 0. So number would become 0. Okay. Next step, append this to a builder. So what we are appending, we are appending remainder. So remainder that's appended to 1, right? Okay. So next step, what we are doing? Next, go to the again while loop. Now number is 0 here. So let's update the number 0 now. We're checking number is greater than 0. No, that is not the case. So this will not enter the while loop, right? So now our conversion is done. Logically, our conversion is done. So only one thing is left here. So what we are got in our builder, it is 441, right? So while we are performing the conversions, we once we perform the conversions, we read it from the bottom, right? We read it from the reverse direction, right? But this convergence, the program is reading from top to bottom. First we are noted down 4, then 4 and 4, right? It means that the builder, right? We have to just reverse the builder and then we reach our result. Let's see what I am trying to say. So let's say builder dot reverse. Builder has inbuilt method to reverse the string, right? And then we will say toString because we are not returning a builder, we are returning a string. So that's why we are just saying toString method. So that's it. So this is our whole program as of now. So what we are doing it, so we are just creating a builder class, and then in a number system we are just checking, we keep on performing the loop operation till it is greater than 0. Like till it is greater than 0 we'll perform remainder and quotient operation. So every step we are noting down the remainder, and then we are dividing it. After that we are just noting down the remainder in our builder class. So this is the logical flow of our program. So let's now clean it up, our program, right? So that it's become bit smaller for our reference. Okay, so this step also I can move it here because we can directly append it. Right, so let's be patient and see what is the exact output we are getting now. Okay, so this is our final program. So we are builder class, we are performing this while loop operation, and then we are appending it every time we are getting the remainder, and we are reducing the number by corresponding target radix system, and at last we are reversing it back, right? So so now next step should be let's keep this aside as of now. Once we go to our editor, right, we will see that how we can see its execution result. So let's keep it aside, this particular guy, as of now. So I am just moving it here. Okay, so there another way we can achieve this result. So we have jdk classes like integer wrapper class. It has couple of methods. So let's see how we can achieve that result using that. Now suppose so very first method is like integers.toString method, right? So what it says that you pass any number. So let's pass any number. We'll define that number, what is that, and we can define the radix number system. Whether we are converting to octal, we are converting to binary, we are converting to hex. That we can define. It is generic method. Like in our case, our target system is 8. Right? Our target system is 8. Right? We are dividing it by 8. Right? So let's pass the radix 8 here. So right, so this guy will give us the result back, right? So if I simply write system.out.println, so I will say simply SOP for our reference here. So let's see, if I pass number, say number is again 100, right? So what will the output here? Output would be 144, exactly what we see here in our actual program, right? So this guy will return that. Okay, there is another method is provided by integer class. So what is that? So in direct method is there to octal, because it is quite frequently used methods, right? So they have provided another helper function uh, which would be directly converted back. So we can use that as well. So let's pass the number here. Okay, right, so let's perform SOP for this as well. We will write in a editor, we will see the actual execution. So I am just, for your reference, I am just mentioning it here, right? So here output again would be 144, right? So this is all about our method that is provided by JDK. Okay, so we have specialized method where we pass the number, we getting the output, and there is one generic method. You pass any target number system, it will convert it back. So both are quite useful methods. Typically we use this kind of helper functions in our day-to-day life in software industry, right? But yeah, anyway, we need to know how it is works actually in our framework, or actually in the background. So that's why we have this program in place. I'm sorry. So now let's move to the editor. Now let's copy paste the code. Let's go to the editor and let's see its execution. Then we'll understand more. Then we connect it more properly, let's go to our editor and let's write the same program there. Okay, this is my editor now. So I am just creating one class. So let me quickly create one class. Say decimal to octal. Okay. I am copy pasting the same method which we have just written over there. Okay, so I just make it as private static private. I am just saying for oops concept perspective because it is just local to my class. Okay, so I write one main method here. Okay, so let's declare a number which we want to perform the conversion. Say number is 100, right? So let's perform some SOPs. Let's write what is input and output so that we know which method we are calling, because we are going to write another methods as well. Okay, so number is number here. Let's print the input number and let's call our output method output, and let's invoke our method decimal to octal and let's pass the decimal number. Okay, so what we are doing, so we are just declaring one integer variable of value 100. I am just printing its input and I am calling this method. I am passing the input whatever is there 100, and then it is perform this conversion operation, and at the last it is returning the string back, right? And we're just printing that string, right? Let's execute this program and let's see its result here. Now let's observe the output here in our console. uh, Now we can see that input is 100 and output in the octal representation is 144, right? This is exactly what we have seen in our demonstration, right? So for 100 system output is 144, right? This is exactly what we have seen in our editor as well, right? Now let's write the methods provided by JDK classes. Okay, so let's copy paste the same code as well so that we can delete it, right? So it is just a SOPs. Let's go to our editor. So let's create a method. Let's name it as private static void. I will call it as JDK integer helper method, right? Let's say one. Okay, that is fine. So I'm taking input, right? The number which we would like to convert to the octal number system. Okay, I am just pasting it from our demonstration SOP. I will change it to system.out.println, right? So let's indent it a bit so that it is more readable. So SOP we change it sys.out.println, right? Now what we are doing here, and okay, there is one brace is extra. Okay, so what we are doing here, we are taking input as a number. We are performing the toString method and passing the radix 8 because we are converting it to octal number system representation. As discussed, this is a generic method, so we can pass any radix, whether we are converting to binary. If it is binary, we pass 2 here instead of 8. If we are converting it to hex, we will pass 16 here because hex, the radix base is 16. And there is a direct specialized method provided by integer class, which is toOctalString. Herein we will pass the input number and it will again give us the output back, that 144, right? Okay, so let's invoke this method. Okay, before invoking, let's say some SOP. uh, let's append some string so that we know we are invoking which method. Like say let's conversion using toString, right? Okay, so it's typo here. Let's Okay, so we use the same kind of SOPs here as well. So let's say 2 octal. Okay, so simply I am just prepending some text here so that we can correlate. So let's invoke our method from main. Let's say JDK integer method. Let's pass number here again. So we are passing the same input number so that we can perform both of operation. Now let's execute our program. Now we'll see the output here, right? So the 144 output, it is from our custom method which we have written here. So for 100 output is 144, and using integer classes toString method, again it is 144, and using 2 octal string it is again 144, right? So it is working as expected. Okay, now let's see in our editor now. So let's quickly recap what we have done. Okay, so we have written one method, number system method, so wherein we have input number 100, and every step we are just noting down its remainder. Okay, so like 100 by 8 we are dividing, and then we note down its remainder, and we are then reducing the number, like number by 8 every time we are doing. So as we are discussed in our demonstration, right, we are dividing by 8 and we are noting down the remainder every step we are performing it, right? So this is what we are doing it here. So at last we are reversing it back, because we have seen in our demonstration we are reading from bottom to top, right? So that's why we've done it. So this is more or less about the program here. So if you want to understand, you can refer back our demonstration here, so where it is exactly the same uh, thing which you are writing it here in the editor. Okay, so you can do that. So one thing I would like to mention, that we have published the article here in our website, right? So you can refer this article here. It is under the beginner section, uh, in core Java section. If you go here, if you go to our website under beginner section, we have published so many numerous articles related to that. So here the one which I am talking about, so decimal to octal system, November 22, right? So here again we have mentioned, right, so we have provided a foundation again here, like base number 6 system to 8, and then what are the helper method provided by JDK classes, and we have written both iterative as well as recursive method. In this video we have talked about step 1 and step 2. 3 recursive we will discuss in different video altogether, because the logical flow is a bit different, so we'll discuss it completely in different video. Okay, these two methods we already discussed, and then this is the program which we are discussing today. Like we use string builder class, and then we are appending it, and we are reducing the number, and at last we are reversing it back. So this was the method, right? So recursive we haven't discussed this today, so we can ignore it for a time being. We'll come back to it later on. Okay, so these are the complete program. We are just using scanner to read it from the user input. In our demonstration, we just provided hard-coded string of value 100. So this is better approach. You can uh, do this way only. This is good way to read it from the console. Okay, so then these are the method provided by us. So this article you can refer. We use the same example as well, so that we can easily correlate to our article. So we try to do that. So this is more or less about this article. So we'll publish the link of this article in our video, so we'll mention in the description of the video. You guys can refer it back. So in case you have any questions regarding to these articles, kindly do let us know. We'll happy to respond you back. So that's it for the today. uh, have a great day ahead. Good day. Bye bye.